Hello everyone. Welcome to our YouTube channel, Equation by Pharmacist Moms. In this video, we will continue our discussion regarding cardiac physiology. Today, we will learn the normal electrocardiogram. Let's begin. An electrocardiogram, or electrocardiograph, that is ECG, or EKG, is the same thing. Electrocardiography, or ECG, is one of the most vital and readily used screening tool in clinical medicine. It is inexpensive and easily obtained in both the inpatient and outpatient setting. An EKG is a test that examines the heart function by measuring the electrical activity of the heart. What are the applications of ECG? Let's learn. The ECG is used to diagnose numerous cardiac conditions, including prior infarction and active cardiac ischemia, as well as conduction abnormalities, such as atrial fibrillation and life-threatening tachycardias. The information provided by ECGs is also used in determining which type of implantable cardiac defibrillator should be used for the management of advanced heart failure. Numerous non-cardiac conditions, including electrolyte abnormalities and medication side effects, are also detectable on ECG, owing to their distinct effect on conduction patterns. How to read an ECG strip. ECG paper commonly moves at 25 mm per second, thus, each small box, that is 1 mm, is equivalent to 0.04 seconds, or 40 milliseconds, and each large box, that is 5 mm, is equivalent to 0.2 seconds or 200 milliseconds. At the beginning of an ECG, note of the standardization square is made, normally 10 mm high by 5 mm wide. This will alert to correct the paper speed and standard amplification of P, QRS, and T wave complexes. 1 mV of electrical activity results in a 10 mm vertical deflection on the grid paper. How is ECG interpreted? A well-planned approach to 12-lead ECG interpretation will prevent the interpreter from missing crucial information. Key aspects in the interpretation of the 12-lead ECG include the heart rate, the heart rhythm, both atrial and ventricular, the electrical axis, both the P-wave axis and the QRS axis, and knowledge of the normal intervals. Next, determine the relationship of P waves to QRS complexes. Finally, analyze the QRS morphology and ST and T wave segments. The different waves that comprise the ECG represent the sequence of depolarization and repolarization of the atria and ventricles. Because the recording speed is standardized, one can calculate the heart rate from the intervals between different waves. Let's discuss normal ECG waves, intervals, segments, and their duration values in detail. RR interval is the time elapsed between two successive R waves of the QRS signal on the electrocardiogram. It normally ranges from 0.6 to 1.2 seconds. The period of time from the onset of the P wave to the beginning of the QRS complex is termed the PR interval, which normally ranges from 0.12 to 0.20 seconds in duration. This interval represents the time between the onset of atrial depolarization and the onset of ventricular depolarization. The ST interval represents the initial, slow phase of ventricular repolarization. The TP segment is the portion of the ECG from the end of the T wave to the beginning of the P wave. This segment should always be at baseline and is used as a reference, as there are no specific disease conditions that elevate or depress the TP segment. The QT interval is the time from the beginning of the QRS complex, representing ventricular depolarization, to the end of the T wave, resulting from ventricular repolarization. The duration of this interval is 420 milliseconds, or less if heart rate is 60 beats per minute. The P wave represents the wave of depolarization that spreads from the SN node throughout the atria and is usually 0.08 to 0.10 seconds, that is, 80 to 100 milliseconds, in duration. The Q wave is generated when the AV nodes releases the signal that travels through the interventricular septum. It is less than 3 milliseconds in duration. R wave is the first positive deflection after the P wave, regardless of whether a Q wave exists or not. The signal triggers a contraction on the left ventricle that pumps blood out of the ventricle. There may be multiple R waves. S wave is generated when the basal parts of the ventricles are depolarized, resulting in the contraction of the right ventricle. The QRS complex represents ventricular depolarization. The QRS complex is normally 80 to 100 milliseconds in duration. T wave is the time at which both ventricles are completely depolarized. The duration of T wave is 160 milliseconds. The U wave is a small deflection immediately following the T wave. The source of U wave is unknown. Three common theories regarding its origin are: delayed repolarization of Purkinje fibers, prolonged repolarization of mid-myocardial M cells, and after potentials resulting from mechanical forces in the ventricular wall. J point is a junction between the termination of the Q or S complex and the beginning of the ST segment. It represents the initiation of ventricular repolarization. The PR segment represents the electrical conduction through the atria and the delay of the electrical impulse in the atrioventricular node. The duration of PR segment is 50 to 120 milliseconds. The ST segment represents the interval between ventricular depolarization and repolarization. This segment roughly corresponds to the plateau phase of the ventricular action potentials. The duration of ST segment is 80 to 120 milliseconds. Now, we will learn the basic physiology of the cardiac conduction system. Physiologically, ECG tracing represents the conduction pathway through the heart. The normal conduction pathway originates in the sinoatrial or SA node, which initiates sinus impulses, and a wave of depolarization spreads out over the right and left atria, forming the P wave. At the level of the atrioventricular or AV node, the beat is conducted to the ventricles, over the His bundle to the right and left bundle branches, and the Purkinje system. The resulting atrial repolarization and early ventricular depolarization result in the QRS complex. Ventricular depolarization and subsequent repolarization lead to the completion of the cycle, forming the T wave. The periods between each wave and complex are made up of intervals and segments. The PR, QT, and RR intervals represent the duration of conduction through the AV node, the duration of ventricular depolarization to repolarization, and the duration between each cardiac cycle, respectively. The PR and ST segments represent the isoelectric interval between depolarization and repolarization of the atria and ventricles. That's all for today. We will continue the discussion regarding cardiac physiology in our next video. Take care.